Alright, in the last lesson I made a little bit of a mistake. I assigned this homework here. This is not the correct homework. The correct homework is page 350, number 2 to 5, 7 to 9, 16 to 19, and 22. As well, you can do this conditional probability. I will post the answers on the My site. Okay, they'll be under the homework for probability. All right, so please do that. We'll now start lesson 5.6. All right, 5.6, independent events. Independent events are events that are not affected by each other. This is simpler because the probability of A and B is just the probability of A times the probability of B. Okay, that's going to seem a little bit simpler. Okay, the key here is that one event in no way affects the other one. So, first example. Mokhtar and Chantal are playing a die and a coin game. Each turn consists of rolling a regular die and tossing a coin. Points are awarded for rolling a 6 on the die. So here's how you get the points. You roll a 6 on the die and you toss heads with a coin. 1 point for either outcome, 3 points for both outcomes, 0 if neither outcome. Okay, players alternate turns. The first player who gets 10 points wins. Determine the probability that Mokhtar will get 1, 3, or 0 points on his first turn. Okay, well, let's quickly go over a couple of things. What is the probability of a 6? This is 1 in 6. What is the probability that you don't get a 6? This is 5 in 6. Okay, and what is the probability of heads? That's 1 out of 2. And what is the probability that you don't get heads? That's also 1 out of 2. Okay, so that's our first step. Then let's make a tree diagram, okay? Because we have a couple of scenarios that are going to happen. Determine the probability that Mokhtar gets 1, 3, or 0. We're going to have to look at each of those 3 probabilities. Okay, so before we do this, let's make a tree diagram here. So first you're going to take the dice or the die, and either you're going to get a 6 or not 6. Okay? And the probability of 6 is 1 out of 6. The probability of not 6 is 5 out of 6. So that's the first possibility. Then from there, all right, you can either get heads or tails. You can probably get heads or tails. And in each case, these are 1 out of 2. Okay, so let's take a look at what is the possibility of rolling a 6, getting heads. This is probability of 6 and heads, which is 1 out of 6 times 1 out of 2. And you can see these are not affected in any way. The probability of getting a head is not affected by the coin, so that's why these are independent events. Okay, probability of not 6 and, probability of 6 and tails. This is 1 out of 6 times 1 out of 2, which is also 1 out of 12. And then we have the probability of not 6 heads. This is 5 out of 6 times heads, which is 5 out of 12. And the probability of not 6 and tails is 5 out of 6 times 1 out of 2, which is also 5 out of 12. Okay. Now, what was the question again? What is the probability that Mokhtar will get 1, 3, or 0 points? Well, how do you get 1 point? 1 point is either outcome. Okay? So let's think about that. What is the probability of 1 point? When does this happen? This is if you don't get a 6 and a heads, or you get a 6 and tails. Okay, so this is 5 out of 12 plus 1 out of 12. This is 6 out of 12 chance. What is the probability that you get 3 points? Well, when does that happen? This happens if you get a 6 and heads. So this is a 1 out of 12 chance. Okay, by the way, where is that? 6 and heads, that's right here. Okay, and then what is the probability of no points? Okay, when do you get 0 points? You get 0 points if you don't get a 6 and you don't get tails. Sorry, you don't get heads. Alright, and there's a 5 out of 12 chance of that happening. Okay, so there's your answer to part A. Part B, verify your results, explain what you did. Okay, the total probability should add up to 100%. So one way to check is to add up all the probabilities, because these are the probabilities of everything happening. So the probabilities should equal 100%. So if we go 6 out of 12, 1 out of 12, plus 5 out of 12, this is 12 out of 12. So all of our possibilities here do add up to 100%. That covers everything. Okay, which, by the way, 100%, another way of saying that is adds up to 1. Okay, let's try another question. So hopefully you've read this question. I want to highlight something that, in this case, the tickets will be returned to the drum. This means that they're independent events. In other words, one event is not affected by the other event because each time the tickets are put back in, so each draw is equal. Okay, very quickly, what's the probability of winning on a draw? Well, if he buys 5 tickets, he has a 5 in 1,000 chance to win. But we're supposed to find what is the chance that he will win at least one prize. Now, there's a couple of ways we can do this. Okay, the first one is to think, well, he could win the first draw, or he could win the second draw, or he could win both draws, right? He could win both times. And if we did this, we could figure out the probability of winning. What is the probability that he wins on the first draw? Well, if he wins on the first draw, this means he's losing on the second draw. Now, notice that, because if we have the probability of winning is 5 out of 1,000, the probability of not winning is 995 out of 1,000. So the same thing happens for the second draw, except this time it's the other way around. If he loses on the first draw and wins on the second, or how does he win both? That would be 5. What is this here? This would be 5 out of 1,000 times 5 out of 1,000. Okay, that's to win both. Now, if we figure out all of these things, we'll figure out what are the chances of winning at least once. So this is 0.004975. This is the same. And this is 0.000025. Now, if we add those all up, you end up with 0.09975, which, if we multiply by 100 to get percent, you end up with 0.9975%, or about a 1% chance of winning a prize. at least one prize. Okay, now there is another way to do this question, and I think we've seen this before. Anytime you have this phrase at least, you could, instead of doing it this way, you could do it as so the probability of at least, we could say that's 1 take away the probability of the event not occurring. Okay, so 1 would be 100%. This would be a 100% chance that it's going to occur. Now, if we take away the probability of it not occurring at all, we're left with it occurring in some form or another. Okay, so here you would go, what is the probability of it not occurring? Of him not winning? Well, him not winning means 995 out of 1,000 for both draws. Okay, and this would give us the same answer. If you went 1 take away that, you're still going to get 0.009975. Okay, so you can choose to do it either way. Sometimes at least is quicker. In this case, I don't know if it's much quicker. I think they're both about the same. All right, so take a look at the summary, and now you can do the homework on page 360. You probably will need a little bit of extra time because I gave you the wrong assignment last time. But please make sure you're getting both of these assignments done. Make sure you also do that the conditional probability assignment on the previous couple pages. Okay,